Good afternoon, everyone.
Good afternoon, ma'am.
Okay, so we are discussing your collection framework, and we just discussed list interface and array list class of list interface. Okay, your array list, vector, and your linked list. These three classes implements your list interface. So we are just discussing your array list class. Yes, so we are just discussing this program. So why we are getting in array list if we are inserting uh, integer type of object elements, then if you are trying to get the sum of that, then you are getting such type of error. Okay, what is that error? It is showing a bad operand type of binary operator, sum is of integer type, and second type is of object. Okay, so here it can add this integer type with the object class. So we know that every class has a parent class, that is the object class. Okay, so in case of your, when you are creating any classes of this collection interface, okay, their parent class is also the object class. So when you are writing this way, so the default object type, it takes the object type, okay, not the integer type, integer wrapper type. It takes it as object type. Okay, so one thing we can do, if we can make that array list class as integer type, then when you add, this type of error will not come. Okay, otherwise if you are not using that, then you have to do the typecasting, but that is the extra burden if you are doing this typecasting. So I told you to do the typecasting and to remove this compile time error. So have you done it? See, if you do this typecasting, you have to do like this. 5 elements you have inserted in sum equals to 0. Then take one by one uh, object and convert it to string type. Then convert it to string type to integer type. Okay. So dot to string, whatever object you are, if this is object type and you are converting it to string type, then string type to this integer type, and finally you can get the sum. Okay, but here you need to typecast all those things. So to avoid this thing, we have the generic. Okay, so what is this generic? Generic means you can parameterize your class type. Okay, generic type means your parameterized type. So The object is the superclass of all other classes, and object reference can refer to any type of object. So this feature lack type safety. Generics add that type safety feature. So what is this type safety? Like in this program, if you want to, if I'll enter al dot add hello string, it will take. It will not show you any error. Okay. I can insert or I can add one double value also, one character value also, like that. So any type of value you can add in this program. Okay. So there is no such restriction. So this is not your type safe. So if you want to make it type safe, you can use generic type. So generic means your parameterized types. The idea is to allow integer, string, your double, all those, and user defined types to be a parameter to method, classes, and interfaces. Using generics, it is possible to create classes that work with different data types. An entity such as class, interface, or method that operates on a parameterized type is called generic entity. So now what are the advantages of it? The mainly three advantages are here. First one is your type safety. So type safety that I told you in if you have done this any array list program, then in that program if you have entered only strings, try to enter integer. If you have entered integer in that program, try to enter some string. So it will easily take it. Okay, no error it will show you. So with generic, it is required to specify the type of object we need to store. So list integer, list new array list integer. So in Angular bracket, whatever we are writing, so this type of syntax we are calling it generic type. Okay. To this array list class, we are passing its type as integer type. Okay. So whatever object you will create, it will be of that type. Other than that type, it will not allow you to store. So when you write is list.add 10, it will take 10. So when you write is list.add 10 within double quote means string type, it will show you compile time error. Then second advantage is typecasting is not required. Okay, in the previous program we saw if you want to do addition, then you have to convert it to string type, then integer type, like that. So that is not required. So simply you have to mention it inside the Angular bracket, then it will work. So here list one example it is showing here. If you want to add this list.add hello, okay, then if you want to store that hello inside the string object, so actually whatever value you are taking in your without specifying the generic type, so all are of object type. Okay, so here also you have to convert this hello as you can see this is written like one string, but it is also it will take as object type, its parent class type. So you have to convert this one to string type, then you can store in your string. But if you use your string type generic type, then directly you can write it and you can get the value and store it in the string variable. No need of typecasting. Okay, this is your second advantage. Third advantage is that compile time checking. Okay, that also you saw in the first example. Compile time checking means when you try to enter different type of elements except that mentioned type, then it will show you error at the time of compilation. So it will throw you compile time error. Okay. So these are the three main advantages of using this generic type. So generic type that you have to mention inside the Angular bracket. Okay. So all of you, if you have done any program of array list, just try to add different type of elements in your program and see the compile time error. So that example that was showing error, that example you can rectify in this way. Array list, here you have to mention the type, what type of element you are going to store inside the angular bracket. So array list integer al equal to new array list integer. Okay, then add the elements, then you can easily find out the sum of it, sum dot plus al dot get then you can get the sum. And here in this program you just try to add one a string like al dot add hello, and see, now it will not take that hello, it will show you error. But in the previous program it can easily take that hello. Okay. So if you have done this program, then just do the modification in array list. Just write there integer. See, all of you do these programs, okay? I think already you have done it. Simply you have to make change in that array list object creation statement. Just you have to put that angular bracket with integer. Done? यस मैम बोल देते, मुझे फिर ये स्क्रीन में आना पड़ रहा है. So same type of program I am giving you to do, only to remember this syntax also. So familiar with this syntax. Write a program to create array list of double type and find the sum of it. Just do it. Write a program to create array list of double type and find the sum of it. Okay, so done. Okay, who are doing the program? Raise your hand. Only two, Abhishek Puri and Prajyot. Rest of the students, you are not doing the program. What you are doing? AD assignment. Soumya, you are not doing the program.
Ma'am, actually today I have joined from my mobile. My laptop is not working. That's why.
Okay. Manas Vishwal, what you are doing? Kamlesh, Anish, okay, Abhishek, you just shared your screen. So those are not doing the program, just say it. Increase your font size. Okay. So you do one thing, you just add one string value. Add a1 dot al dot add. There you write. Al dot add L50, where you are adding at the end, you just add one more element. Yes. Just write there hello or something. Okay. Semicolon. Semicolon. Okay, you can see at this time it is showing you that error. So tell me the error, what it is showing. What is written? The method add double in the type. I can see. Array list double is not possible. I think like that some for the argument string. So that means when once you have declared your array list of type double, it can take any other type of values. Okay. Okay, you stop sharing. Yes. Okay. Priti Kar. Priti. Puspendra.
Yes, ma'am. Doing just 2 minutes.
Okay. Siddhant.
Yes, ma'am.
Doing the program. Shashank. So next is your, so this is one example of your array list class. Next classes of your list interface is your vector and linked list. So next we'll discuss your vector. So what is your vector is like whatever the methods we are using in array list, same methods we are going to use in vector. Now what is the difference between this array list and vector? Array list is not synchronized, vector is synchronized. Okay, so when this term synchronized, not synchronized is coming, that refer to your threading. Okay, whether it supports your threading concept or not. So array list is not thread safe, vector is thread safe. Multiple thread can use it, but multiple thread can't use your array list. Okay. Second difference is array list increments 50% of current array size if the number of elements exceed from its capacity. And vector increments 100% means double the array size if the total number of elements exceeds than its capacity. So what do you mean by it? So default capacity of, though your array and vector can increase its size dynamically, the number of elements we want to, as many number of elements we want to store, we can keep it in your vector and in an array list, but some default capacity is defined for it. Okay, for array list and vector, some default capacity is defined. So the default capacity of array list and vector is 10. Okay, so when number of elements exceeds that 10, array list increases its capacity to 50%. 50% means it will allow to store 15 elements. Okay, suppose you are inserting 11th number of element. So what your compiler will do, it will increase the size of that or capacity of that array list to 50% of its current size. So current size 10 hai. So 11 number of elements you are inserting, so it will make increase its capacity to 15. But in case of your vector, it will increase its capacity to 20. When you enter 11th number of elements, it will increase its capacity to 20, double the array size. It just make 50% of the array size, it will double the array size. Okay. So when, let's say you have entered 20 elements, then you are entering 21 element. So what will do it again? Double the array size, means 40. Capacity becomes 40 like that. Okay. And in this case, it will be 30 like this. So array third advantage understood. Then third advantage is array list is not a legacy class. It is introduced in JDK 1.2. Vector is legacy class. Array list is fast because it is non-synchronized. Vector is slow because it synchronized. Array list uses the iterator interface. A vector can use iterator interface or enumeration interface to traverse the elements. Okay, but now in newer version also your array list can be traversed with enumeration interface. So these are the few difference between your array list and vector. So this is showing in your book, one example is showing regarding that capacity. Okay, so in vector also we can define the user defined capacity and how many, means how it will increase that size when, or capacity when it reach at its capacity, given capacity. So that also you can do. For example, here vector v is equal to new vector 3 2. So what do you mean by 3 2? So 3 is passed as the initial capacity, and 2 is the, this way you have to increase the capacity. Means when you will enter fourth element, the capacity becomes your 4. Okay. So when you increment, when you enter fifth element, the capacity, so it will double the capacity, not 4, it will double the capacity. Sorry, it will add 2 with that capacity. So means 3 means it will next time when you enter fourth element, it will be 5. Okay, capacity becomes your 5. So when you uh, so when you enter sixth element, the capacity becomes 7, like this. Okay. So by 2, this capacity will be increased. So initially, what is the size of this vector? What is the difference between size and capacity? Size means what is the current, how many current elements are there in that vector, that is the size. And capacity means how many elements it can keep, that is the capacity. So initially there are no elements in your vector. So size will be your 0. And what is the capacity? Capacity here we have provided 3. So capacity it will print you 3. So size 0, capacity 3. So here initial size is 0, initial capacity is 3. Now it is go on adding the elements. So vector dot add element method is there in your for your vector class. So here it is going on adding the elements. Okay, 1 2 3 4 like this. Then it is when it so the capacity we have declared 3. So when it is adding the fourth element, and if you print the capacity will be incremented by 2. So 3 will be your 5. So you can see the capacity after 4 addition is 5. Okay. Then you enter one more element, so that will within that capacity. So this is the fifth element. The capacity will remain that 5. So when you add this sixth element, capacity will be incremented by 2. So that will be your 7. Okay. Now capacity is 7. So this way, this will go on incrementing the capacity. Okay. So about so how it is. So next is it is showing the first element and the last element of this vector. Calling this first element method and the last element method, it is showing the first and last elements. So first is 1 and last is 12. So those two elements it is showing, and it is checking whether 3 is present in that vector or not. So for that it is using the contains method. Okay. So using contains method you can check that element is present or not. And the next is it traverses that vector using this enumeration. Okay, so how to traverse using enumeration and iterator, that we'll see uh, after 2-3 slides. Okay, so you just remember that there is one enumeration interface and you can create the reference for this one by using this elements method. Okay, there is also okay, so an elements method, then your enumeration has two methods. One is your has more elements, another one is your next element method. So vector enumeration object dot has more elements. So has more elements will check whether any more element is present in that vector or not. If it is present, it will return true. Then it will print you or fetch you the next element. So this way it is traversing the vector, and you can simply also print that vector or traverse the vector using for loop also. Okay. So will you do this program?
Can you explain that capacity part again? 3 comma 2.
3 comma 2 means here we are declaring its initial capacity,
Yes, ma'am.
a
That is
vector.
initial and it will increment to that is it, right?
So it will increment it by 2 when it reaches its initial capacity. Okay. So whatever so like here,
It will not go
your
to 4. If we will add the fourth element, it will go to 5 capacity.
yes, when
Yes,
you 5, so when you enter sixth element, it will increment 5 to 7.
okay, okay, got
Okay,
it.
when you
It will
enter
keep incrementing.
by 2. So when you enter eighth element, it will increment its capacity to 9 this way.
Yes, ma'am, got it. Thank you.
So next is your another class of your list interface is your linked list. Okay. So here this linked list class implements a double linked list. Okay. And in data structure, I think you have done the code or you have written the logic for how to store the elements at the beginning, at the end, at the middle position, how to remove the elements from from the beginning, from the end, from the middle position, like that, and to search whether this element is present in the linked list or not. So all those code for that algorithm you have written. But in your collection in framework, it gives you the ready-made methods, okay, predefined methods. Only you have to use those method names to do all the operations of this linked list. So this is one example. So in this linked list class, it is adding the string type of objects, and how it is adding for inserting add method is there. If you want to add it at the first position, then add first method is there. If you want to add it at the end position, then add last method is there. Okay, and for specific position, you can pass the index position and that object means that string. Then you can also remove the element by its reference name or by its position. You can remove first. You can use the remove first method to remove the first element. You can use the remove last method to remove the last element, and contains method to check whether that element is present or not. Okay. So this is the program for it. So you do one thing, just quickly execute this program. Quickly execute this program. See why I am saying to do, many times I have repeated, to be acquainted with these methods, with this syntax, like add last, add first methods are there. Okay, if MCQ are there, uh, what is the method to insert the element at the beginning position? There may be the methods written like add begin or add first with F small letter or A with capital letter, F with capital. So in various form that name may be written. Okay, once you execute the program, that will be printed in your mind. So that's why I'm saying execute the program. Otherwise, no need to execute. We know that what will be the output of this program, and these are the simple things. Simply you have to write add last, add first. No logic is written there. Okay. So a few programs I'll skip also. That you skip means I'll explain, but I'll skip you for you not to execute in this class. But that you have to execute after the class. Okay. So according to this, first it will add A, B. At the end it will add this C. Okay. Then add first. So before A it will add D. Then add 2E, means in the second index position it will add this E. Okay. So that will be your 0, 1, 2. Okay. 0, 1, 2, yes, 0, 1, 2. So in this 0th index position already we have added D. So in the 0th index position D is there, first index position A is there. Then after DA it will add this E. So D, A, E, B, C. Then it will add F, then your G. Okay. Then what it is doing, other operation, it is removing. Remove B, so it will remove B. Remove 3, so after removing B, so B is in the, okay, we'll see here. This is your linked list. Then remove B, so it will remove B. So C index position will be your 3, 0, 1, 2, 3. So remove 3 means it will remove C. Then remove first means it will remove D. Then remove last means it will remove G. So what are the remaining elements? The remaining elements are A, E, F. Then it is displaying that remaining element, simply printing that linked list object. Then it is checking whether the E is present in that linked list or not. So contains method returns your boolean value. So if so that boolean stat means for status it is taking stat. So boolean stat equal to obj contains E. Yes, it contains. So true value will be returned to here. So then this statement will be executed. List contains the element E. Okay. Then what is just printing the size of the current linked list. That is your 3. So this is your program. Done this one?
Yes, ma'am.
Okay. So next is your queue interface. Okay. So your priority queue implements your queue interface. Also your linked list implements your queue interface. Linked list implements your list interface, also your queue interface. Okay. Why it is so? Like when we are doing the coding, when we are implementing your queue, so there what we are doing, you can create your queue using array, or you can create your queue using linked list. Okay. So just a second. You can see this image. This is the picture of your collection interface. So you can see your array list, vector, and linked list implements your list interface. That dotted arrow indicates implements, and that solid arrow indicates your extends. So array list, vector, linked list implements your list interface. You can see here also linked list implements your queue, priority queue, and linked list implements your queue interface also. Okay. So now come to this priority queue. So normal queue we know that is in the FIFO order, first in first out. Okay, the principle of queue is FIFO, first in. The element which is inserted first will be removed first. Okay, like your in real life also, when you are making the queue, the person who is at the front, that person is coming out first. So first in first out, the principle. In case of a priority queue, it gives the priority to the smallest element. Okay, the smallest element will be removed first. It is not that which one is inserted first, that one will be removed first. In case of your priority queue, the smallest element, by default, the priority is given to the smallest element. So the smallest element will be removed first. Okay. So this is one program of a priority queue. So the object creation is like this. Okay. The object creation of all the classes are same. Only you have to change the class name, and then what are the methods? Using this add method, it is inserting the elements. So here it is inserting the strings C, Java, Python, C++, like that. So how it will take the element? So it will actually store it in ascending order. Okay, smallest, so that it will remove the smallest one first. So first it will, if you remove, so if you call the remove operations, and then it will remove C first, then your C++, then your Java, then your Python. Okay, alphabetically dictionary order it will remove it. So few methods are used here, like pick. What is the pick method? Pick method only show you the front element or the first element. It will only show you. But there is a method called poll method. Poll method will remove the first element. Okay. Pick only show you the first element, but it will not remove. But poll will remove the first element. Okay. So here it is traversing. See, simply using the loop you can traverse, but iterator enumeration interfaces are there. Using those interface, you can traverse the collection classes. Okay, so that interface I'll show you how it is working, or how we can traverse through that. You just see here iterator interface, then the reference name equal to PRQ. PRQ, the object of this priority queue class, dot iterator. Okay, so here iterator is the method which creates that reference. Okay, then using this itr1, you can call this HajNext method. HajNext method is the iterator interface method which will check any more element is present in that uh, class, means in that priority queue or not. So you can use iterator for array list. If you use the array list object, then it will check the element in the array list. If you are creating the object for the linked list, then it will check the element in the linked list. Okay, so what type of object you are using, so that object type element it will search. Then system.out.println itr1 dot next. So it will search the next, get the next element, and it will print the next element. Next is so it is calling this poll method. So as I told you, poll method will remove the head of the queue, means the first element of the queue. Okay. So again it is after removing, again it is traversing and showing the elements. Then it is removing Java. Okay. Then it is checking whether C is present or not, like that. So you can see. So after removing an element with call function, what are the remaining elements? C++, Java, Python. Okay. Then after removing Java, there are C++ and Python. Then it is checking whether C is present or not. C is not present in that priority queue. So it will return you false. Okay. So I'll moving to the next interface. Do you want to do this program? See, in one slide, I'll show you this traversing different ways how we can traverse the uh, collection classes. That I'll show you one slide. So in that slide, we'll do this program. Okay. So this is your list and your queue interface. So next one is just set interface. So before that set interface, first we'll see this iterator and enumeration. Okay. Okay. So your iterator is an interface that iterates the elements. Okay. It is used to traverse the list and modify elements. Iterator interface has three methods which are your has next, next and remove method. Okay. Enumeration functionality is also same. We can traverse through using the enumeration interface, but it has only two methods. That is your uh, has more element and next element. Okay, but there is no remove method in case of your enumeration. So what are the different ways to traverse the list? The different ways are: one is your for each method, for each loop, then iterator interface, then the general loop, that three-part for loop, while loop, enumeration. So in these six ways you can traverse the list or any collection classes. Okay. So this is one example how to traverse the array list. So three elements are inserted here. Array list object is AS, array list integer AS, new array list. So iterator, so what type of list it is going to traverse, that type you have to mention. So in iterator integer it equal to as dot iterator. Okay, as that is a defined object name, reference name as dot iterator. So here this iterator method will create some reference so of AS type, so that will be stored in your IT. Now using this IT, you can call this has next method to check any more element is present or not. If it is present, then it will print the element using this next method. Okay. Just execute this program quickly to remember this syntax, how to traverse using iterator. Execute the program. Done?
Done, ma'am.
Okay. So this is a program. In this program, it is showing all different type of traversing ways. Okay. So using so it is storing string elements in this array list. That is for each method. Okay. So one for each method using so how you can call that for each method. You can call it by the class name. So array list dot for each. Then this is actually one lambda expression. Okay. So s arrow system dot out dot println s. So what it will do here, like in your unlike your for each loop, you have to mention the type. Okay, like in the second type of traversing for string name colon array list, then you have to write that string name is of string type. So here no need of that. Once you mention once you call that for each method using the object, so automatically it will know that it is of array list type. In the array list you have mentioned its string type, so it will take it and simply print the values here in case of a for each method. And for each loop syntax, you know how to use the for each loop. In the array list you have stored the string type, so simply write one variable with that string type, then print the name. Okay. Then next is your three-part loop. That syntax also you know. Then how to get the element using the get method. You can get the element of that array list and you can print it. Then using this while loop, here it is using the iterator interface for this while loop, and that we just did now. Then next is your uh, next so that again another type means same type of, that is if you are not mentioning that type, okay, how you'll do that, it is showing. So this is the older version. Next is enumeration type. In case of your enumeration type, you have to, like in iterator you are calling iterator method, here you can call the enumeration method. Okay, so how we'll call it using the collections. So what is this collections here? I told you there is two words, confusing words. That is, one is your collection, another one is your collections. So collection without s, that is the interface, and collections is the class, utility class. So you can call the collection class enumeration method and pass that array list object. Then you can traverse using this enumeration. So e dot has more elements, enumeration has the method has more element. Okay, iterator has the method has next, and iterator has next method, enumeration has next element method. Okay, so using this enumeration you can traverse this way. So these are the output of it. Okay. So you just execute the different ways of traversal. And the simplest way is simply write system.out.println that object name. So it will print you all the elements. But if you want to do some modification, some manipulation with that, with particular element, and you are so in that case, you can traverse the list. Shall I change the slide?
Yes, ma'am.
Chutuvant, what happened? Done. Okay, so done it. Shall I change the slide?
Just a minute.
Okay. Done?
Yes, ma'am.
Okay. So next is your set interface. Okay. So set is another interface which implements your collection interface, and set interface has three classes, that is your hash set, tree set, and linked hash set. Okay. Unlike your list, what your set interface, what is the feature of this set interface? Set interface doesn't allow duplicate elements. Your list interface allows duplicate elements. Set interface doesn't allow. Set interface doesn't preserve the order. Okay, it doesn't preserve the insertion order. So that's why we don't have that indexed based methods. Indexed based method means like get method. In that get method, we are passing the index value. In case of your arrayed list, we know in the second index position this element is there, or in the third index position this element is there, and either you can store the element in that position, or you can fetch the elements from that position. Okay, but here we don't know where the elements, in which position the elements will get stored. So that's why that index based add method and that get method is, add method is there, but that it is means position argument, that one is not there, and the get method is not there. Okay. So in case of your sorry. So two things. One, it doesn't allow the duplicate. Second, it doesn't preserve the order. Okay. So some important points about hash set class. Hash set stores. So your hash set is a class of your set interface. So hash set stores the elements by using a, so how it is storing the elements if it is not storing in the insertion order, it uses your hash code to store the elements. It generates the hash code of that element, then it is storing it there. So hash set stores the elements by using a mechanism called hashing. Hash set contains unique elements only. Hash set allows null value. Hash set class is non-synchronized, doesn't maintain insertion order. Hash set is best approach for search operation as we are using the hashing technique here. So this is one example. Here you can see how to create the hash set object, simply writing the hash set class name, then that parameter, then the object name, new hash set. Add method you can use here. So a dot add 1, 2, 3, 4. Again 3 is repeated, means duplicate element 5. Then when you traverse, you can see what will be the output. Output is here 5, 1, 4, 2, 3. There is no particular order. Okay, and you can see here it is not showing that the 3 twice. Only once it is taking that 3. So twice it will not take it will not take the duplicate element. So this order of element according to the hash code of those elements. Okay. So if you do this program, do it quickly. You can do it. You can do it. You can do one thing. In your array list, such type of program already you have the adding the elements. Okay. So in that place, you just write do on separate file. There in place of array list, just write there hash set. Okay. And iterator method is already in this previous program. Okay, this previous program in this program. Yes, I have shown you. You have used this iterator. So in the same program, you can use the hash set. In place of array list, just write the hash set. Okay. And try to add the duplicate elements there. So in your book, same type of one example is given. Okay, string type of values are added. Then multiple null values are added, but it takes only one null value. And repeated, like here mango is repeated, orange is repeated. So one copy of that it is taking. Even one copy of null value also it is taking. Okay. finally it is displaying that hash set. So this is your book example. So next is your linked hash set. So linked hash set is like your linked list. So difference is in case of your linked list, it takes the duplicate elements, but your linked hash set doesn't take your duplicate elements. Okay. And in case of a linked hash set, it takes the or it preserves the insertion order. Okay, like you have inserted Z R M O K K E F G. So, and here it is 95 13 0 55 33 61. So in that same order it is showing to you. Then next is your tree set. So tree set stores the element in ascending order. Okay. So here it also doesn't allow you the duplicate value, and it shows the elements in ascending order or stores the element in the ascending order. Okay. You can see in this example, EFG stores, test, pens, ink, journal, like these strings are there. So while you print this tree set, it is showing you in this ascending order, E first, then your I, J, P, then S, then T. Okay, so this is the output. E, F, G, ink, journal, pen, stores, test. It will show you in this ascending order.
Excuse me, ma'am.
Yes.
How has set print the value?
Hash set, it is not taking any order. Okay. It doesn't follow your ascending or descending or insertion order. Simply by hash code, it is showing the output. It generates the hash code for it, then it is showing the elements.
So if we want to find the order of the output, then how can we?
For that, you have to know the how the hash codes are generated.
Okay, ma'am. Got it.
Okay. So these are the three classes of your set: hash set, linked hash set, and your tree set. Linked hash set, it doesn't show any order. Okay, it follows your hashing technique. It takes the hash code. In case of your linked hash set, it preserves the insertion order, and your tree set, it shows you in ascending order. And both these three classes are not taking any duplicate elements. Then next is your map interface. So here in your book, one table is given, what is the order, how it is sorted or not, everything is clearly written, so you can go through this table, so easily you can grasp that which class is following which order, or is it sorted or not, all those. So you can see has set implements this set interface. Order, no. Order, sorted, no. Tree set, yes, it is sorted by natural order. So that is actually, it is in ascending order it is displaying. Then linked has set, order by insertion order, and sorted, no. Okay. So you can go through this table to remember all these classes, order, and whether it is sorted or not. The next is your map interface. Okay. So map interface is separate interface from your collection interface. Collection is one interface, map is another interface. Okay. Like your list, your set, all are belongs to this collection interface, but map doesn't belong to your collection interface. So map structure is different. You can see this is your map interface. Okay. So map interface has this hash table, hash map, hash table. This one extends your dictionary, and this gray color shows you the abstract classes. The solid black color shows you the classes, and that dark gray color is your interface, like this. So you can see this map interface structure. So in your book, from this map interface, your tree map, hash table, and linked hash map. These four classes are discussed. Okay, so those four classes we'll see one by one. So here you will take 10 minutes of break. So after the break, we'll discuss this map interface. Okay, so take 10 minutes of break now. So all of you are present now.
Yes, ma'am.
Okay, so now what is speciality about this map interface? So in like your set, list, all those interface, it is taking single values. Okay. So at one at a once it can take one single value only. In case of your map interface, we can take pair of values. Okay, that is the key value pair. So like you can store student registration number, student name. Okay, like that, employee ID, employee name, or something like so. Pairs, so pair wise we can store in your map interface classes. So what classes we'll discuss now? We'll discuss your hash map, linked hash map, and another one is a tree map. Okay, and like your hash map, there is your hash table. So these four classes we are going to discuss one by one. So before discussing all this, the few methods it is using. So about that first we'll discuss. Then we'll see how the programs are written. Okay, so so this map interface. So actually there are two interface for implementing a map in Java. Means for this mapping purpose, one is your map, another one is your sorted map. Okay, and the classes are your hash map, linked hash map, and your tree map. So on basis of key, if you want to like according to the student registration number, you want to search something, or you want to update some record, or you want to delete. So for that, your map interface is useful. Okay. So your map contains values on the basis of key, that is key and value pair. Each key and value pair is known as an entry. Okay. And your map contains unique keys. So like first in your table, so each entry is called your row. Okay, you have written student name, registration number, age, address, all those. So one row. So in table we refer it as row, and in map we refer it as entry. So entry, it takes only two values. Okay. So your map doesn't allow duplicate keys, but you can have duplicate values. Okay. Your hash map and linked hash map allow null keys and values, but tree map doesn't allow any null key or null values. Okay. And another thing, we can't traverse your map classes. We can traverse. To traverse the map classes, you have to convert it to set type. Okay. So how you will convert it to set type? Using either key set method or entry set method. So this key set method or entry set method converts that map type to set type and return the set type object. Okay. So here the description of these three classes. Hash map is the implementation of map, but it doesn't maintain any order. Linked hash map is the implementation of map. It inherits hash map class. It maintains insertion order. Tree map is the implementation of map, and sorted map, it maintains ascending order. Okay. So like hash map, there is hash table also. In case of your hash table, so the hash map, hash table methods and features means how it operates. They are like similar, but few difference is there. What are the difference? Hash map is non-synchronized. That means it is not thread safe, can be shared between many threads without proper synchronization code. Hash table is synchronized, it is thread safe and can be shared with many threads. Hash map allows one null key and multiple null values. Hash table doesn't allow any null key or value. Okay. Hash map is a new class introduced in JTK 1.2. Hash table is legacy class. Hash map is fast. Hash table is slow. We can make the hash map as synchronized by calling the code synchronized map method. We can make the hash map to function like synchronized methods. Hash table is internally synchronized and can't be unsynchronized. Hash map is traversed by iterator. Hash table is traversed by enumerator and iterator. Hash map inherits abstract map class. Hash table inherits dictionary class. Okay. So these are the few difference between these two. So this map interface is not the subtype of a collection interface. Okay. And we in this map class, whatever the class we'll use of this map interface, there we'll use one interface that is called a map.entry interface. Okay, so that map.entry interface has provides some methods that we are going to access the map. So how we can how you can access it. So it has some methods like an entry set method. So entry set method, this method will return one set type of object. Okay, the entry set method declared by the map interface returns a set containing the map entries. Each of these set elements is a map.entry object. Okay. Get key method will return you the key, get value will return you the value, and instead of add method, here we'll use put method to insert the elements, pair of elements. So here, this is showing the example of hash table and hash map both. So you can see. So in this class, ID1 in this class, first we see the hash table implementation. The hash table, so two pair it is taking two values as a pair it is taking. So here it is taking one integer, one string. Okay, you can take any pair. So integer string, new hash table, integer string. Now put the values st dot put. For integer, it is 101, string Ajay 101, Vijay 102, Ravi 103, Rahul, like this. Okay, so here you can mark the key value are repeated, means duplicate key values are there. Okay. Then how to traverse this hash table? As I told you, first you have to use the entry set method to convert it to set type, and through the map entry interface reference you can traverse the map. Okay, so map.entry m is colon for each loop colon st.entry set. Okay, then you can print the values one by one. M dot get key, M dot get value. Okay, this way you can traverse the map classes. Next is the hash map implementation. Same code, simply you have to, in place of hash table, you have to write the hash map. Okay. So you can see in the previous case we have taken duplicate key value, means in hash table we have taken 101 twice, so it is taking only 101. Okay, so which one it will take, that we can say. So 103 Rahul, 102 Rabi, 101 Vijay. So actually if we see 101 Ajay we have taken, then when we are writing 101 Vijay, actually that value Ajay value is overwritten, that is Vijay. So that it is taking the second one, that is the Vijay. Then the hash map, in hash map I think we have not taken any duplicate value, so it is printing all the values. And another thing is that hash table prints the values in descending order. Okay. So in hash map it is showing in ascending. Actually in hash map it doesn't print in ascending order. So here it is showing in ascending, but a hash table always print it in the descending order. Okay. So you first execute this program, then we'll discuss the next one. Execute this program. Tell me when to change the slide, okay? Okay, respond to your names. Soumyasri, Soumyasri, Anushka,
Present, ma'am.
Dipasa,
Present, ma'am.
Ayush, Anish, Subham Das, Soumya,
Present, ma'am.
Abhijit,
Present, ma'am.
Abhishek. Okay, Abhishek mic is not working. Roshan, Falguni,
Present, ma'am.
Prajyot,
Present, ma'am.
Angana,
Present, ma'am.
Aniket, Anisha,
Present, ma'am.
संचाली,
Present, ma'am.
शताब्दी, सिद्धांत, अर्नव,
Present, ma'am.
Present, ma'am.
अर्नव दत्त,
Present, ma'am.
अर्पिता, अर्पण, दिया किरण,
Present, ma'am.
गीतिका, हर्षित,
Present, ma'am.
मानस, कमलेश,
Present, ma'am.
रश्मिक.
Yes, ma'am.
Okay. Shall I change the slide?
Yes, ma'am.
शशांक,
Present, ma'am.
मेहुल,
Present, ma'am.
संजोग,
Present, ma'am.
अभिलाषा,
Present, ma'am.
संबित,
Present, ma'am.
अंकित,
Present, ma'am.
निश्चय, प्रीति,
Present, ma'am.
राजेश,
Present, ma'am.
रक्तिम, रौनक, पुष्पेंद्र,
Present, ma'am.
आदित्य नारायण,
Present, ma'am.
ऋतिक,
Present, ma'am.
रोशन, शहनाबाज,
Present, ma'am.
अनिमेश,
Present, ma'am.
शुभम,
Present, ma'am.
वैभव,
Present, ma'am.
सचिन, शुभजीत,
Present, ma'am.
सुप्रीति, सूरज,
Present, ma'am.
शुभम,
Yes, ma'am.
श्वेता, उदित नारायण,
Present, ma'am.
उरुसालम, विवेक,
Present, ma'am.
अंजलि,
Yes, ma'am.
सत्यव्रत,
Present, ma'am.
आदित्य नारायण, रोहन,
Present, ma'am.
चितवंत,
Present, ma'am.
अनन्या, अनिमेश,
Present, ma'am.
अंशुमन,
Present, ma'am.
श्रुतिकीर्ति, आयुष,
Present, ma'am.
निखिलेश, तनिषा.
Present, ma'am.
कितने सारे प्रेजेंट्स यहाँ पे लिखे हुए. अर्पण, अर्पिता, शुभम, रोशन, Okay. Okay. So all of you executed this program? Who has done this program?
Yes, ma'am, done.
Anybody else has done this program? So in your book, this is your implementation of your hash map. Yes, hash map, and taking one integer value, string value, and using this iterator has next method is this traversing this hash map. Okay. So initially it has to convert to set type, set1. You can see set1 equal to hash map 1 dot entry set. Then it is taking that set1 object, it is calling the iterator method, then traversing the hash map. So you can see here, okay, in case of your hash map, in the program I have shown you in the slide, it is just displaying in the ascending order, okay, but that is not like that. It can print it in any order. Actually, when it is printing it in any order means that taking that hash code, okay. So 14, 33, 16, 7, 19. So when you are printing it, it is like your 33, 19, 7, 14, 16, I think removed or what. So like this it is showing the values. Yes, remove 16, 16 is removed. But when it is taking the value for the hash table, key1, key2, key3, key4, key5, it is displaying in the descending order. Okay. So, but one thing it is written here, actually that output is not coming, but it is written here that keys are printed in descending order from key 4 to key 1. Okay, in our case also, in that slide also, it is printing you in the descending order 103, 102, 101 in case of your hash table. So here also it is saying the same thing, that it is printing in descending order. But what it is saying, the last key always show you the last. It will not will come in order, but actually it is not showing in the last, at the last. So here it is entering E5 at the end. Okay, but if you run this program, I think it will come like 5, 4, 3, 2, 1. 5 is not coming at the end. Just execute this program. Just execute this program quickly. Execute this program quickly. Have you executed?
Yes, ma'am.
So in which order it is coming? What is the output?
First key 4, then key 3, key 2, key 1, then key 5.
In that order it is coming.
Yes, ma'am.
Okay. Okay, you just use this enumeration type in this program, in this slide program, and you print it. Tell me which order it is coming. Is the last one is coming at the last? Here the last one is 103. But it is at the beginning it is coming 103, 102, 101. Hash table, but done it. Okay, Abhijit, you just share your screen.
Yes, ma'am. I'm getting error due to some reason. This code, the earlier code it's running.
43215 is coming.
Yes, ma'am.
And if you write this enumeration traversal in the previous one,
In that case, I think because of this is an integer, it's giving me error.
so you have changed. You have to change accordingly, na?
Figure it out.
Where you have written integer.
Oh, yeah. Mhm. Next element.
Mean NMS dot has more elements. Then where is that NMS? NMS is your enumeration type. Enumeration type. NMS. अच्छा. तो NMS को इंटीजर टाइप कास्टिंग को वहां से हटाओ.
Okay.
नहीं, इंटीजर को पूरा वहां से हटाओ तो. उसको फिर एक सेकेंड. नेक्स्ट एलिमेंट इसको टाइप कास्टिंग करके नेक्स्ट एलिमेंट इज ऑफ इंटीजर टाइप. इंटीजर एनएमएस क्या दिखा रहा है इधर?
Ma'am, cannot convert from object to string.
Okay.
We have to give the key in string form.
No, not necessarily you have to give. You just okay, for now you just check it with that K1, K2, give it. Our purpose is to check whether it is coming in which order the last element is coming at the end or not. To do one thing in place of 102, 103, just write K1, K2, K3 like that.
Here.
Huh? Make it K1, K2, K3 like that.
K1, K2. Like this.
String type.
Okay.
So there you have to make it a string.
Yes, ma'am. Yes, ma'am.
This one a string. Yes, then it.
K5 is printing first.
K5, K4, K3, K2, K1. So K5 is not coming at the end. Okay. Just okay, you stop sharing your screen.
Okay, ma'am.
Okay, so it is written in the above. Okay, you can see the key are printed in descending order. If the collection is value by different order. Okay. So we'll see this one. Okay. Actually, if you find the hash table order, actually it is not ordered. Okay. It will come actually in any order. It is means randomly it comes. Okay. But here it is showing in its light example. It is showing the descending order, and in the book it is showing descending, but the last one at the end. But if you find it hash table shows you in random order. Okay, I think for the key values it is just hash code is like that. It is printing in the descending order like that. But actually, it is in random order. Okay, that's why. But I think in your book it is written for this particular type of example. It is coming that last one is at the end. Otherwise, there is no such logic to print the last one at the end. Okay, so next is your tree map. So your tree map is the ordered one. Okay, means it shows one order, that is the ascending order. Okay, so you can see here the key values it is taking. So tree map, the integer string, so pair of values it is taking. Then integer value, for key it is 1, and for value it is object 1 like that, 17 object 2, 50 object 3 like that. And while we are printing, it is printing it 1, 3, 1, 3, 7, 17, 50. So it is your 1, 3, 7, 17, 50. So accordingly the values are get printed. So it shows you in the ascending order. Okay. So when this tree map or tree set, so in that case, when the tree is coming means it will show you in the ascending order. Okay. Next one is a linked hash map. Okay. So this linked hash map, it takes your two values, implements your double linked list, but takes two values. Okay, in your linked list case or hash linked list case, it takes single values. Here it is taking double values. Okay, two values, pair of values. So linked hash map, li map. Then you just put the values in the linked hash map. Okay. So here in which order? It is in the insertion order. 21, 35, 1, 300 like this. So you can see it is coming in that order. 21, 35, 1, 300. Okay. So in this order it is showing you the linked hash map. So all these collection classes means whatever the collection classes given in your book interfaces that we discussed. So one is your list, another one is list, then queue, then set, then map. So these four interfaces and their classes we discussed. Okay. So in your book you can go through. Here you can see, yes. So hash map ordered, no. Hash table ordered, no. Sorted, no. Okay. Tree map sorted. And tree set sorted. Okay. Linked hash set, no. Ordered in by insertion order. So you can see which one is ordered, which one is sorted. Okay. Okay, so your collection part is over. So we left this generic part. Okay. So your generic type or generic programming is also called your parametric polymorphism. Okay, because same program, same template has different form. We can have their integer type of values. We can have their string type of values. Okay, double type of values. So main benefit of that is that to code reuse means once you define its template or its frame, you can use it. So without rewriting that code again. Okay. So one example, how to declare it for that template to create that template or to create that frame. You have to use some notation you have to use. For this parametric type, you have to use this T. Okay, T specifies what type of element this class is going to use or this method is going to use. Okay, for that you can use this T. So for example, here class, main class, integer, string, boolean. So this class, main class, this main class template only can use only these three types. Okay. So this is the example how we write the generic type, public class, box T. So T describes the type of the object used, then private T. So in this place you can write the type integer or float or double like that. Then the method public void that int T, okay, for example int T or double T or float T. Then public the return type also we have used here the T. So E is used to specify the element, key A is used to specify the key, V is used to specify the value. And if you more than one parameter you are using there, you can specify this as you like that. Okay. Okay. So you do one example, you do it. Okay. So this is the frame given. So according to this frame, this is the template given to you. Okay. So according to, so in this template, you just do one thing. You use integer type and double type and show the value. You execute this class for integer type and double type and show the value, corresponding values. Can you do it? Do it quickly. You
Can
have,
you repeat?
huh?
Can you repeat the question?
Here the template is given to you, generic class is given to you. Okay.
Yes,
In
ma'am.
place of your T, you just put the integer value. In place of T, you just use the double value and print the value. Means you have to use this class, you have to call for the integer value, you have to call for the double value and print the corresponding values. Understood?
Yes.
Do it. Subham Patnaik, are you doing the program? Attend. Anjali, Suraj, Ayush, Chituban.
Ma'am, can you show that code again?
Which code?
That generic one only.
You open your book. This one.
Yes, ma'am, got it.
Okay. Okay. Abhijit completed. Rohan Harichandan, are you doing the program? Siddhant,
Yes, ma'am, doing.
those are not doing in your system, at least try to recall and write it in your copy. Okay, I'm showing you one. See, This is your generic type. Okay, class box T, then private T, public void add T, this dot T equal to T, so public T return type is, so this is like your replace method. Okay, so whatever you will pass the type, same type will be replaced with it. So then I have used this show type method. So show type method will show you which class it belongs to. So in the main method, you can see I have created the integer type of object, okay, integer class type, and here in the angular bracket you can see box integer, okay. So this class box is of integer type. This is box. So then your box string. So this T will be a string type, okay. Then what I am doing, I am calling this add method. One add, it is not the predefined, it is user defined add method I have written here. Here it is inserting the or initializing the value to the data member. So this dot T equal to T. Okay, so data member will be initialized with the value 10, and second one for the string it will be initialized with hello world. Now next I am calling the get method. The get method return type is corresponding type. If it is calling integer type is calling, then the return type is integer. For string, the return type is string. So in place of T, integer will be placed, and in for the string type of call, string will be placed. Then in show type, it is showing the integer box dot show type. It is showing that java dot lang that integer, and in string box dot show type, it is showing you java dot lang dot string. Okay, so here you can see we have defined only one frame, and you can use different type of parameters. Okay, no need to write this. If you will not use like this, suppose I'll define here integer T and the type I'll define, then again and again for same code, same logic, I have to write it multiple times. Okay, so this is your generic type of programming, one example. Have you done your program?
Yes, I'm done.
Uh, Siddhant done? And those are not doing, just see the program. Okay, how the generic program will write.
Ma'am, just 1 minute.
Okay. See, in generic type, many things are there, okay. But in your book, just introduction type is given, a simple one, how to write the generic one. So the detailed discussion we are not doing here.
And is it required to pass that new integer and new string?
No, if I'll not write like this, it will work. That's why that strike mark is there.
I mean, in case of a string, like we can directly pass the value, or
In string type,
Yes, ma'am. Ma'am, I will say.
just a second. Okay, I'll run it. Okay.
so is both makes any difference, or it's same?
So it is creating through constructor we are creating there. Okay. So here we directly passing that literal. inside your code. And in case of your this something is not happening.
Your voice break.
Okay. I think I was disconnected for a while.
Yes, ma'am.
So this is directly we are passing the literal to this add method. Okay. So in this add method, you can see this is T. So string type T, T. So this is like for T equal to hello world. Okay. Like string T equal to hello world, and the previous one, what is written initially, that is the string T equal to new string hello world. Okay. The difference we described in the string. So that is the difference here. Understood?
Yes, ma'am.
Okay. So one example is given here. Means suppose you want to restrict the type. Okay. Suppose you want to restrict the type. For example, here you want to like here you extends your number. Okay. So like there is bounded type, unbounded type, means only which type of in which type of class you can use this extend. Okay. So for that you can write like this, u extends like that. Okay. So here it is written u extends number, means in that place you can pass this integer or some wrapper type of class, so which can only extend the number class. Number is the predefined class. Okay. So here when you are writing like this, box integer box new box integer box dot set new integer 15. Okay. So what it is, integer box is the object of this box class, then it is calling this set method new integer 15. Okay. So set method here, this set get all are the user defined. So set new integer 15. So 15 is passed and this t member is assigned with the 15. When you are calling this get method, it is simply returning that 15. So you can get here that 15. Okay. Set new integer 15. Actually the complete program I think is not there. So it will work for this integer 15. But when you write like this, integer box dot inspect some text. Okay. So here what is this inspect some text? So here inspect method is defined here. In inspect method it is written u extends number void inspect u. What does it mean? Means it only extends your number class. So integer type will work with it, double type will work with it, but your string type can't be or it will not take the string type. Okay. Because we have mentioned what this u type only extends your number. Okay. So in u integer can be passed, but this string type can't be passed. So that's why it will show you error is the error is written here. Error is presented since this should still be returning a string. Okay. But here it should be of integer type. Okay. So that's why here this error is coming. You can see that is described here also. So here it is saying that one benefit of using this generic method, which is to bound the parameter and ensure only restricted type that can be employed as the method argument. This can be achieved by creating the upper bound for the type and use the extends keyword like this. U extends number. Okay, only what type of value you can take, so that upper bound is you can mention by using this extends keyword. This is an excellent example of using a method which works with a locked number type. Since we have inserted some string in the inspect method, this directly translates to string object. This means that the compiler finds that the method cannot work with this available information. Okay, it will only work with the number type. Then next is your overriding toString, hash code and equal. So why we need to override these three methods, toString, hash code and equal. So you know what is the use of toString method. So toString method returns you the string type of object. So when we execute our program, so internally your compiler will call one toString method. If we have not provided, then the compiler will execute this toString method. Okay, so but why, when we need to explicitly override this toString method, so when let's say for example, if you want to print directly one object value, okay, like in an array list, we can directly write the array list object, so it will show you all the contents of array list. Or any collection framework classes, if you directly write system.out.println that object, it will show you that content of that object. Okay, but for the user defined classes, if you want to print that, it will not print you the content. Okay, like student S, then in your student class you have the registration number, name, all those data members, and if you want, you have taken all the value for the registration number, age, address, and finally you want to show the values, you can't write system.out.println S. Okay, so if you write it, what it will happen, it will show you some value in the undesired form. Undesired form means it will show you the class name, one @ symbol, then the hash code. Okay, for example, this is your class car. Okay, in this class car, you have created car equal to car, new car. Then if you simply print this car, it will not show you the value. Or if you write this car.toString event, it will not show you the car value. What it will show you? It will show you that class name. So here it is the entire package it is showing. Then the class name @ the hash code it is showing. Okay. For example, here class student, roll number, name, city, then student. Here it is, these values are assigned. Okay, inside the main method you are taking these values for S1 and S2. Now suppose you want to print system.out.println. Okay, so what will happen? It will not show you the desired output. It will show you in this form: student @1FEE6FC, student @1EED7786. So these are the hash code values. Okay, so if you want to print these values 101 Raj Lucknow like that, then what you have to do? You have to override the toString method. Okay, so what you will do? So inside the toString method, you write the code so that when you print the S1 or S2, it will print you the values. Okay, so you can see in this second program, this toString method is overridden. Public string toString. Then what it is returning? It is returning the roll number, name, city. So when you print this S1, so what will happen? The toString. So when you are not overriding, compiler will provide you the toString method which prints you in this form. So if you provide the toString method or override the toString method, compiler will not call the default one. It will call your toString method and it will print you the values. Understood? Yes or no?
Yes, ma'am.
So quickly do this program. In this program, you just do one thing. Don't take the 3 data member. Only take 1 data member and see what output is coming without toString method and what output is coming with toString method. Quickly do it. Or you will do after the class. Okay. So next is your overriding your equals method. So where we need to override the equals method, if you want to compare to user defined class object, okay, using your equals method, it will not compare. Okay. So in that case, you have to override the equals method. Okay, so equals method I will discuss tomorrow. You do one thing, you execute this one. Overriding equals method will discuss tomorrow. Okay, so here is your quiz link. Just a second. So in your chat box, quiz link is given. Appear for the quiz first. Respond quickly. I'm going to deactivate the link. Okay, I'm deactivating the link. I have released your score. You can check your mail. Answers, set has contains method, yes, true. Linked list implements both queue and list. Then which method, that is your remove last. Then to change element, you can use set method. Linked hash map maintains insertion order, it is true. Okay. Okay, so your time is over now, so you may leave. So tomorrow we'll complete this chapter 13 and also chapter 14. Okay, you may leave now.
Thank you, ma'am.